So this is Dr. Kavita Singh, Associate Professor, Department of Civil Engineering in Institute of Aeronautical Engineering. So today we are going to discuss our topic will be for discussion on history of GIS. So in the previous lectures related to GIS, we have just studied about introduction to GIS. So introduction to GIS, what is GIS, what is the definition of GIS, what the GIS do, what are the different applications of GIS, why the GIS is useful and how it is helpful to the users. Now we are going to discuss today what is the history of GIS, from where it came, when it started, and what is the current situation and what will be the future situation of GIS. So this all we are going to discuss today. So before we just discuss this all, we have to go through this contents what we are going to discuss. That is about history of GIS, the early history of GIS, the first GIS, GIS today, and the future GIS. So first thing what we have to see here is what is the history of GIS, when it started. So if you see, GIS started in late 90s, 1960s and early 1970s. So it is long back started. So GIS has its roots in the stimulates provided by the development of remote sensing in the late 1960s and early 1970s as a potentially cheap and effective source of Earth observation. So that time when the GIS started, there was no much facility. So they used to just capture the images through parachutes and the local devices. From there, they used to prepare the maps based on that images. So GIS was late 1960s, it was like not that much developed. But nowadays, if you see today GIS, it is very much developed. It is so much useful and it's very much helpful by using the GIS software. By sitting at one place, we are able to do the survey of the place and we are able to get the geographic information and all the topography. So the field geographic information system started in the 1960s. As computers and early concepts of quantitative and computational geography emerged. So early GIS work included the important research by the academic community, and many of the techniques for processing remote sensing data are highly specialized. More general GIS techniques become important in order to combine information and derived from the remote sensing with other collateral information. So remote sensing process was the process we have discussed in the previous lectures also while discussing about remote sensing. The remote sensing will give us the data. So GIS will help us to display the data. So remote sensing process where the techniques, due to the technique, the GIS were getting the important data and all, and based on that data the information was displayed. So in order to combine the information derived from remote sensing with other collateral information. So GIS has many routes of evolution like map production process. So one route, like for example, one route lies in the landscape architecture and environmentally sensitive planning, and the other route, it lies under the urban and demographic data analysis. So it has many routes, but out of that routes, one route is related to the landscape architecture. So what is landscape architecture and the environmentally sensitive planning? So these all are important in the urban planning also. So in an area, the information about the landscape, the architecture development of the different construction works and environmentally sensitive planning, this GIS has one route where it works, and the other part of GIS works in the urban development and the demography of data analysis. Demographic data analysis means all the demographic data, and the urban developmental activities are considered under this route. So these two routes are under this evolution of the GIS routes. And the route of remote sensing merging with vector GIS, the route of larger scale data GIS gives people the ability to create their own digital map. So there are some more routes like route of remote sensing will be helping us to merging with vector GIS. What is vector GIS? That will be learning in the coming lectures. So just for information, I'll just let you know vector GIS is about related to the information about point, line and point. Okay, related to the information about point, line and polygon. So by taking the information from the remote sensing data means by taking the satellite imagery or by taking the topo sheet data, what we are going to discuss, we are going to merge with the vector GIS. Vector GIS means we are going to create our own map with the help of this point, line and polygon. So creating the map with the help of point, line, polygon means representing the entire information based on this point, based on this line, based on this polygon. So point will look like this. This is the spatial information. So line will be in this symbol form and polygon will be in this symbol form. So these are the three features which we use to merge with remote sensing, we merge with vector GIS. And further, the root of larger scale data GIS gives people the ability to create their own digital map layers to help several real world problems. So it will help us to create our own map with the help of this point, line and polygon. These three types of features will help us to convert the remote sensing data to a vector GIS. So vector GIS is helpful to us to create our own map with the help of these three features, and we can just convert the analog data to the digital map with our own creation we can do. So this is how the GIS is helpful, and GIS has also evolved into a means of data sharing and routes of remote sensing merging with vector GIS, the root of larger scale data. So continuous overlapping interpretable GIS database of world about virtually all the subjects. Today, hundreds of thousands of organizations are sharing their work and creating virtually for all the subjects, right? So continuous overlapping and interpretable GIS database of the world, right? Overlapping maps, overlapping images, what we can receive from the remote sensing data. So remote sensing will give us the overlapping images. Overlapping images means, suppose this is one area. So this area, it is captured, this information is captured, then the second information will be captured from here to here, right? So this portion will be having the common area. So this common area is called as the overlapping area. So overlapping and interpretable GIS. Interpretable means the information which is to be which is in the readable format, right? The map which is shown here and we are able to read the map language is called as interpretable GIS database of the world. Now, based on this overlapping and interpretable GIS, nowadays thousands of organizations and hundreds of organizations, they are sharing their work and creating the information virtually to all the subjects. Now we are able to see this GIS in the virtual form, right? So today hundreds of thousands of organizations are sharing their work and creating millions of maps every day to tell stories and reveal patterns, trends, relationships about the everything. So they help us now GIS is so much helpful, like we can just create all the digital information to a vector GIS process, so that we can, with the help of this point, line and polygon, we can create billions of maps based on our requirement and based on our creation. So all the world, like they can just share their information based on this map creation with the vector GIS. So today the term GIS tend to be applied whenever geographical information in digital form is manipulated, whatever be the purpose of that manipulation. Thus, using a computer to make a map is referred to as GIS. Now, if you see the early history of GIS, so early history of GIS, just we have seen in the previous slides also, it started in 1960s and early 1970. So early GIS work included important research by the academic community. Later, the National Center for the Geographic Information and Analysis, led by the Michael Gutschei, and formalized research on key geographic information science topics such as spatial analysis and the visualization. So later when we, before it was only for the research and the academic community, later what happened, this National Center for the Geographic Information and Analysis, led by the Michael Goodchild, he has just formalized the research on the key geographic information science topics such as spatial analysis and the visualization. So this is how the early history of GIS looks like. And so if we remember, like in the previous days, when anybody has to travel, they used to just carry this kind of maps, handmade maps, and they used to just travel. There was no provision of this digital GIS, and there was no provision of this GPS system. So they used to just take this kind of maps, and they used to just travel in the direction by seeing this map, right? So this is the history of the GIS. In early days, this was happening. Now, the first GIS. So when you talk about GIS, whenever you talk about GIS, first of all, you should know who was the father of GIS. So Roger Tomlinson was the father of the GIS. He only started this and he only named it as GIS. So Roger Tomlinson's pioneering work to initiate, plan and develop the Canada Geographic Information System resulted in the first computerized GIS in the world in 1963. So in 1963, he computerized the GIS work of the Canada Geographic Information, and the Canadian government has commissioned Tomlinson to create a manageable inventory of its natural resources. So later, once he converted this Canada Geographic Information System to a computerized form, then the government has given him the given him the commission to manage the inventory of the natural resources of the Canadian environment. So he envisioned using computers to merge natural resource data from all the provinces. So Tomlinson created the design for automated computing. He only created the design for the automatic computing to store and process large amounts. So he was the person who made the GIS that much helpful, where you can design or you can just make it automatic computing to store the process. We can store the process in large amounts and of data, which enabled the Canada to begin its national land use management program. So once the data was computerized, when the data was stored, when the data process was stored in the large amounts, then the Canadian government was able to manage its resources based on this GIS automated system. Now he also gave the GIS its name. So he is only the person who named it as GIS. So GIS is Geographical Information System. So Roger Tomlinson was the father of GIS, who has developed this GIS process and the software and the automated computing system in the 1960s. Now, if you see in the Harvard Laboratory, so while at Northwestern University in 1964, Howard Fisher created one of the first computer mapping software programs known as SYMAP. So this is the person Howard Fisher. He just created a software to make the map. So previously, in the previous days, we used to just create the map with the hands by surveying the area. We just go to the place and we just survey the area, and we used to create the map based on some scale, right? Based on some scale, this map was prepared. Okay. Later, what happened in the 1964, Howard Fisher, he created one of the first computer mapping software known as SYMAP. Okay. So in 1965, he established the Harvard Laboratory for Computer Graphics. He established the Harvard Laboratory for the Computer Graphics. So slowly the GIS started converting it to a digital format. Okay. Now, while some of the first computer map making softwares was created and refined at a lab. So it is also became a research center for the spatial analysis and visualization. So same the Howard Fisher, he just first computer map making software he made, and he created refined at the lab. He just refined that software at the lab, and he also became a research center for spatial. It also became a research center for spatial analysis and visualization. So many of the early concepts for GIS and its applications were convinced at the lab by a talented collection of geographers, planners, computer scientists, and others from many of the fields. Now, ISRI is founded. Later, the ISRI was founded. What is ISRI? So, this is the symbol of ISRI. We can say symbol of ISRI. ESR. So, what is ISRI? ISRI is Environmental System Research Institute. Okay. So, this is the institute where the ArcGIS, where the different kinds of latest software were developed in this institute. Okay. So, in 1969, Jack Danger, a member of the Harvard lab, and his wife Laura founded Environmental System Research Institute. So, these are the persons: Jack Danger and a member of Harvard lab. That is, his wife Laura and the Harvard Danger founded the Jack Danger founded the Environmental System Research Institute. Okay, ISRI. So the consulting firm applied computer mapping and spatial analysis to help land use planners and land resource managers make the informed decisions. So the company early work demonstrated the value of GIS for problem solving, and ISRI went on to develop many of the GIS mapping and spatial analysis methods now in use. So these results generated a wider interest in the company software tools and workflow that are now standard in GIS. So nowadays in all the companies, most of the companies, they use different softwares of GIS to create their own spatial analysis and create their own mapping system. Now GIS goes commercial. So as computing became more powerful, ISRI improved its software tools. Now slowly this ISRI, the computer became more powerful. Then ISRI has developed its software tools, and working on the projects that solve the real world problems led the company to innovate and develop the robust GIS tools and approaches that could be broadly used. So slowly when the GIS has improved and it came to a computing system, when it came to a more powerful and it has a more good amount of storing device with a good backup and with a good improved software, then later the working with the projects of the real world problem, it became easier and it solves the problems in the company and innovate to develop the robust GIS tools and approaches and could be broadly used. Now ISRI work gained recognition from the academic community as a new way of doing spatial analysis and planning. So ISRI work gained a recognition from the academic community, and a new way of doing spatial analysis and planning was developed. So in need of analyzing an increasing number of projects more effectively, ISRI developed ArcInfo, the first commercial GIS product. So this ArcInfo was a very good product when it was developed. So it was having the capability of digitization, making drawings, assigning the locations, okay, and converting line to polygon. So it was developed, the software was developed previously, and the commands was given to the software to convert these all operations. So that time when the ArcInfo was developed and the technology was released in 1981, from 1981 this ArcInfo software was used to make the maps, to prepare the drawings, to assign the locations, to assign the geometric locations, latitude and longitudes, and the technology was released in 1981. and began the evolution of Esri into the software company. When the evolution started of Esri, and then it has developed in the software country. So previously it was Arc Info. Now I'll tell you, we have the same on Arc Info, which is converted to the ArcGIS. Okay. Now it is known as ArcGIS. So this ArcGIS is a very much user-friendly software, and it is very good software. It is a combination of many softwares. If you combine many different softwares, like if you combine ArcInfo, if you combine ArcView, if you combine any AirDAS, different softwares or GIS softwares, if you combine all the software together, then finally you will get ArcGIS. This is a very good software for nowadays. It is very good software for preparing the maps, assigning the coordinates, assigning the location, making your own maps, converting the information to a digital form, displaying the map. Lot of things we can do with this ArcGIS software. So this is developed by the Esri again. So this is the latest version, like ArcGIS 10 we are using, ArcGIS 11 we are using. So which is nowadays fully developed software, which can be helpful to just create the maps in few seconds, in few minutes, and it will give you very exact results out of it. Nowadays the companies are using this software. And now if we talk about GIS today, so how the GIS today the condition is. So GIS gives people the ability to create their own digital map. Yes, so we are discussing this. That's what we are discussing. So it is very much helpful to create your own map. So if you have a satellite image, if you have an image, if you have a data, so that data, if you want to convert it into your own digital map, you can just do with the GIS process only. So it helps us to solve the real world problems. So GIS had also evolved into a means for data sharing and collaboration, inspiring a vision that is now rapidly becoming a reality, a continuous overlapping and interoperable and GIS database of the world about virtually all the subjects. So today, hundreds and thousands of organizations, they share their work and they create billions of maps every day to tell stories and reveal the patterns, trends, and relationship about everything. Now, future GIS. So, future GIS, how will be the future GIS? So, with its movement to web and cloud computing and integration with the real-time information via the Internet of Things, GIS has become a platform relevant to almost every human. So, it is nowadays. GIS is collaborating, GIS is integrating with Internet of Things, it is integrating with the web and cloud computing, and it is doing wonders to the companies and giving a very good results out of it. Uh, and it is the best part that now future GIS is going to be more developed, so that our results will be more accurate, and it will be very easy to just share the information with the other company, and you can just go through this future GIS to almost every human network or nervous system of the planet. So as our world faces problems from expanding population, loss of nature and pollution, and the GIS will play an increasingly important role in how we understand and address these issues and provide means for the communicating solutions using the common language of mapping. So I was telling, like nowadays, as in future GIS, the problems of populations will be easy to solve. Right, we are able to just find out the proper figure of the population and how much area is lost, and how much nature is lost, and how much area is damaged due to disasters, and how much area is damaged due to pollutions. So GIS will play the increasingly important role how we understand and address these issues. We can just address these issues with a common language of the mapping. So we instead of data in the attribute form means data in the attribute form, instead of attribute data in the figures. We give the data in the figures like 1, 2, 3 information if you get. Instead of that, we are just going to display the information in the form of map. Okay, like this in the form of map, so it will be more easier to understand convey the information to the others. So this will be helpful for the users and companies, those who are working on these issues. And government will also just take a it will be very helpful to the government to take an advantage when we work with on this kind of issues. GIS in the future it's going to be very much going to give a very good results out of it. Our works will be becoming more easier when we work with this kind of condition. So ArcGIS nowadays it is very much developed software which is used by the companies or used by the users to create new different projects and get a good result out of it. This is about the history of GIS. So it started in 1960s. In 1980s, our info was developed by the Esri. Now, present situation is we are using ArcGIS with the help of this institute, Esri Institute only. They have just released this ArcGIS software. So these are few contents related to this. These are few references related to this topic. MNG ready book, like oftenly I will say for the every lecture, you can just refer this book for getting the information about this history of GIS, how it worked, and you can just go through this content to find out just more information about this GIS, history of GIS. And later, if you want to know more information, just you can just refer this Stanchion GIS book, Remote Sensing in GIS by B. Bhatia. So I hope you understood about the GIS, history of GIS, how far we came from 1960s to now we are in 2024, how the GIS process is working on and how we are able to solve the issues of different environmental issues and different problems with the help of GIS because it is applicable in almost all the fields, either government sector, either private sector, almost all the fields it is working. Okay, so that's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.